Hi everyone, we are back and now we're going to go over the fundamental root locus rules. So there are several rules that help us design, and there's rules that cannot be violated in a root locus plot. So rule 0 is there must be symmetry about the real axis, excuse me. So it's always symmetric with respect to the real axis. Reason being, complex poles appear in conjugate paths or pairs, so they mirror each other about that real axis, and we can actually see that really well illustrated here, right? So if this moves and goes up here, we need to basically mirror that behavior about that real axis, the x-axis. So rule 0, we have to have that real axis symmetry. So that is rule 0. Pretty easy, right? If only all the rest of them were so simple. Rule 1, the number of branches and the endpoints. So we have our function L of S, and it's a numerator over denominator. So we know that the number of poles is going to be basically the poles of the denominator. We also know the number of zeros is going to be essentially our M here. So the number of branches and endpoints are going to be as follows. So the root locus will have n branches. So you have different branches for each different number of poles, one for each pole. So I have to have, for each pole that we see here located, there needs to be n branches. M branches terminate at finite zeros. So there's n branches depending on our m number of zeros, that many. So for each zero, there's going to be the same number of branches that terminate at those zeros. N minus m branches will go to infinity, or approaching basically asymptotes. And remember, we have to have n must be greater than or equal to m to preserve causality. So I think it's always easier to see when the rules are violated. So rule 0 is violated here. Why? I need symmetry, right? So if this pole is moving like this, I need this pole to kind of move exactly and finish up here about that axis. So this is violating rule 0. What rule is this violating? So what's the number of poles here? 1, 2, 3. So there's 3 number of poles. How many zeros? 1, 2. So there's two zeros. So that means I need to see n branches. So do we see basically, do we see 3 colors here? No, we only see 2 colors. So already that's a violation. Additionally, this is kind of a joke problem too, or not a joke problem, but the way that you draw these, they have to originate from like the location of the pole, right? So the pole has to move from the pole starting point, right? So this is violated already. Do we have m branches terminating at finite zeros? So basically 3 branches, 2 of them should terminate. So this is kind of weird anyways, it doesn't make sense. But we have multiple things terminating here, so that doesn't make sense either. And we should have n minus m, so 3 minus 2. So we should only have 1 basically going to infinity. So this is just violating every single aspect of that system. So now let's go to rule 2. So rule 1, we can see essentially that violation. Rule 2, real axis segments. So a point S on the real axis belongs to the root locus. This is actually another important rule. If the total number of poles and zeros to the right of S on the real axis is odd. So rule 2 is really, you test it with this, what's called the vertical line test. So point S on the real axis belongs to the root locus. So basically any point on the real axis. So we'll lie on that root locus if the total number of poles and zeros to the right of it on the real axis is odd. So let's go ahead and let's visualize that. So let's go to the right here. So if we do a vertical line test to the right, we know basically is odd. So will that be on the real axis? So for 0, again, 0 is even, right? So there's not going to be basically a point on that real axis. If I drew a vertical line here, right to the left, or basically right to the left of it, right? So if I draw a point right here, should the root locus kind of travel basically on this axis? Well, no, because if we go over here, the total number of poles to the right on the real axis is odd. So we see actually, well, no, this is not the case because this is not, basically we can visualize that here. These are, the total number of poles here are 2. So everything to the right of that, so this should not be on that. So that's a Rule 2 violation. So that is really, really critical. A point on the s-axis on the real axis belongs to the root locus if the total number of poles and zeros to the right of s on the real axis is odd. We'll be going through a couple of examples. Rule 3, the asymptotes of branches going to infinity. So we know that there's n minus m branches that will go to infinity. The asymptotes will intersect that real axis at this, basically at this particular point, and depart at this particular angle. So we can calculate and actually determine whether this is true or not. This is a little bit harder. You'll have to find essentially those locations. And there's an even more complicated or longer rule, the angle of departure on arrival. We're going to calculate that essentially using this value. This is tedious, and really we're going to only use that for basically precision analysis, but it can be performed. So let's go ahead and we can actually work through this with an example, and we'll go that next time. We'll see and verify essentially that we're not violating any of the rules, and we can see how to verify each of those systems. So we'll see you next time. Thanks. Bye.